As two chefs were hiking in the highlands of Scotland near Calvine, they suddenly saw an object and hid behind some bushes, for then to take a photo of the object. Here is the photo, and with the premise above, let us try to dissect the surrounding scenery. Viewpoint A. The view that contains the standard orientation. Now let us start out by using the Blender 3D software tool in the process of trying to get wiser on the matter. From this angle of the photo, we get different kinds of information. And if we are to build upon the most relevant, we will now set our focus upon the close distant plant fauna. The viewer is subject to a small branch in the bottom left corner that seems to be the outermost needles on a small bushy pine tree. Secondly, in the top we observe some small-leaved branches hanging down, which most likely are from a birch tree. But so far, something very important is missing in the scene, and that is the ground of which the photographer is placed upon when taking the shot. While the ground is placed in the negative space outside the frame of the shot, the visible fence is also located quite close to the photographer. In the bottom there are also some mountains to the left and shadows to the right that seem to display a contour of round treetops. This last mentioned content will not be handled in this video. The airplane with different left-right wing lightning that seems to be behind the diamond-shaped object will only be elaborated upon minutely. List of explanations by most likely common objects. We now move into the debunker's arguments for what the object can be. And here is a list of the most likely real-life objects that is put forth as explanations. An above-water bedrock tip, reflection upon a pond. A square-shaped kite. A balloon. Viewpoint B. The above-water bedrock tip explanation. The view that contains the reversed and upside-down orientation. This explanation suggests that the photo contains a pond that reflects various content. As the hillside ground within the Scottish Highlands areas consists of a stony bedrock, the bottom of a small water body should be rocky. This becomes relevant if we dive into the above-water bedrock tip explanation. At this point, we will have to change our point of view and make the photographer's camera angle steeper. And while doing so, the frame can now contain a pond reflection that implies a reversed and upside-down orientation of the shot. Due to rules for perspective and distances, this changes the assessed position of the little pine tree that now has to be located closer to the pond than the birch tree. As most debaters who lean towards a logical phenom argument tend to back this explanation, we will dissect this proposition in the most detailed manner. The above-water bedrock tip explanation. Detail A. The front edge of the bedrock tip. While trying to mimic the reflection of the tip, one would want to start out with a tip volume that resembles an elongated pyramid when seen from a top view. The above-water bedrock tip explanation. Detail B. The horizontal line conundrum. Within the 3D software, it is possible to set the light source in such a way that the required shadow appears in front of and below the tip. But if we go back to the photo's all-important horizontal line, we quickly discover that the given volume's shape will force a cluster of very strict demands of the shot angle. If we elaborate upon this view from a separate setup, the principles of perspective require the shot to be taken at a very low angle, which again opposes the recent premise of the steep angle shot that also includes the trees and the fence. Although this weakens the above-water bedrock explanation, there is still an opportunity for the tip to be shaped in a very special way. So let us try and do so, and alter the stone tip's volume. Please notice that there is very little difference in the color of the tip and the color of its reflection within the 3D rendered world. With this particular clip section, we alter the pond's reflective properties in order to point out and disseminate this very crucial part of the whole scene. Now, when we have come close to having a tip that mimics the explained tip on the reversed photo, we should still try and compare the adjusted tip volume to how loose stones present themselves in ponds and rocky waters. So in this small sample size of 12 images, it becomes very clear that horizontal lines seem quite rare amongst water lines between above-lying stones and the water bodies they lay within. The above-water bedrock tip explanation. Detail C. Colors within the mirrored front area. Let us now continue to elaborate upon the colors of the real-life stone examples. For best practice regarding RGB color and light comparisons, we divide them into two categories. The first category looks upon the cases of semi-transparent water bodies, and the other one will contain examples with opaque water bodies with full reflection. This division of the stones is a sorting method we will use as an extra precaution. Although with minor effect, it should mitigate that the water reflections can contain different color complexities due to the object's surroundings. We will now revisit the example clusters of stone image reflections, for then to compare it with the two proposed tip and reflection areas in the photo. The results are a color difference average of 20.5% for the semi-transparent examples, and a color difference average of 9.7% for the opaque examples. So if we now calculate the difference for the diamond-shaped object and revisit this slide, we find that the color values between the proposed bedrock tip and its reflection results in a difference of 28%. Due to the very rasterized nature of the original photo, different samples were taken. The sample with the lowest found difference value still resulted in a difference of 18%. Although the airplane in the image is controversial, we can still, and finally, use this flying object to do a minor comparison regarding light direction. If the diamond shape is really hovering and, as such, is not a bedrock tip that connects to the rocky bottom, the brighter wing contains the same light properties as the diamond-shaped object. The shading seems similar, as both the upper airplane wing and the top diamond shape appears brighter. Last mentions. The next two explanatory subjects will be touched upon in a brief yet efficient manner. The explanation of a square-shaped kite. The explanation of a balloon. The explanation of a square-shaped kite. If the square-shaped kite explanation should make sense, the bought or self-made design would have this dark and light side appearance. Furthermore, the very extreme and yet string-constrained angle makes the kite scenario very unlikely. Here is a small collection of boys holding and/or running with a kite. If one were to compare this stock footage of a square-shaped hobby kite moving around with the Calvine photo object, one would discover that a 90-degree string-constrained angle almost never occurs. The kite will extremely seldomly be in a position where the backbone stick is positioned in an angle parallel to the ground. This unless the controller of the kite is dragging the kite with a great force and with an angle that is very perpendicular to the ground of which the controller is placed upon. This is an effect that we persistently observe in other similar examples as well. Take for instance this photo of a boy that hauls a kite in a park. Never during this clip will you observe the kite move to a position with an angle that is parallel to the ground that forms a 180-degree horizontal line. In fact, one should perform a very specific action of a very hard towing exertion as seen on this illustration. And due to the very erratic dynamics of a kite in the wind, this position of the object would only exist in a split second before moving itself into a new position with a non-horizontal angle. The design of the kite seems odd in comparison to other kite designs in the 1990s. One should assume that the proposed kite in the Calvine environment was photographed in light conditions with a sun angle from above. This implies that the kite would be hit by the light source from above, which force the design to have a dark and bright appearance and look like this. The explanation of a balloon. In order to fulfill the argument of the balloon explanation, two premises will have to apply. The balloon should first of all be filled with a lighter-than-air substance that makes the balloon hover. Secondly, the girders or framework within would have to be strong enough to give the balloon a sharp-edged and diamond-like appearance despite being filled with a gas. Now let us try and simulate what happens to a diamond-shaped balloon when it gets filled with gas. Normally the surface material of balloons are made of thin and lightweight substances. In this image, the hovering and diamond-shaped object is estimated to possess dimensions between 2 and 25 meters in length. By common sense and first-hand knowledge, balloons of this sized aerial vehicles do seldomly contain a strong inner structure. Older Zeppelin balloon types contained a wooden structure just below their outer surface. But this is not the case for modern blimps. Modern blimps contain so-called ballonets, which are inflatable themselves without girders. Normally, the following premise to such a structure would imply that strength will cause a foreseeable weight trade-off. As sticks are lighter than steel, the latter will in practice never be used in a lightweight balloon. And the most likely compromise would be to use a carbon fiber structure. As such, carbon fiber sticks do have more elasticity than steel. Here is the final visual estimation of the most likely appearance should the diamond-shaped object have been a balloon. Conclusion for the different scenarios. Reflection of a bedrock tip upon a pond or lake with a still water surface. Having a bedrock shape with very straight contours is very improbable, and as I had to move vertices within the tip shape, the probability of this reoccurring in nature is almost non-existent. My color analysis part shall also be multiplied to the equation, which diminishes the percentage even further. A very optimistic likeliness for the object to have been The Scottish rock bed pointing up over a still water surface will, in my opinion, reside around 0.5%. A kite. Although the sharp edges points in the direction of a kite, the angle, position, and color design all decrease the credibility for this explanation. I will give this explanatory option of a kite 0.5% of likeliness. A balloon. Having bought helium for ordinary party balloons recently, I conclude that the diamond-shaped balloon almost certainly would have been filled with hydrogen, which is lighter and has a better lift capacity. This is a much more rare gas to come by in domestic settings, and the local Scots behind the so-called fake scene would have been forced to buy an expensive hydrogen bottle on the industry market. Based upon my analysis above, I will initially set this option at close to 0% likeliness. But during the production of this video, a series of Medillín cases has proven that balloons in certain scenarios still can have some straight exterior lines in their designs. Within the particular Medillín sightings, we see plus 10-meter objects hovering for hours over the city, which puzzled many observers from a distance. The root cause lies within a giant hot air balloon tradition from the Mecha quarter in the city. Watch the links below for both Medillín sightings, the correlating news reporting, and balloon close-ups from the Mecha area. The straight lines of those balloons should immediately push the identification meter up to 5 or 10%, but the cloth-like skin of Mecha balloons shows that the slight bulging effect still affects the shape. At the front of the balloon, the shadow contours contain a gradient and not a sharp line as the diamond shape from Calvine. The likelihood of a more flat-shaped balloon with dimensions between 2 and 20 meters and an almost metal-restricted exterior shape hovering in the Calvine area in 1990 is therefore small. I will give the explanatory option of a balloon 1.5% of likeliness. Within the remaining approaches, like the photo being staged CGI or subject to other photo manipulation, few likely scenarios stand out. As the CGI technology in the 90s were very limited for common people to access and make visually credible, and as prior analysis has reached the conclusion that determines the object to be hovering, I will claim that the certainty level for confirming a logical common object explanation is 5% at a maximum. And this analysis will therefore support a UAP conclusion with a level of at least 95%. As a final postscriptum, there is still the Harrier-like object in the photo. Considering that there, according to military sources, were no Harrier airplanes at the Scottish Highland position at the time, the arrow points towards the photo being fake. As the above-mentioned hovering conclusion diminishes the diamond-shaped object as being part of a photo-manipulated setup, the totality of the present objects will require further/other analysis to produce more profound conclusions in the future. It will maybe require other approaches and/or hypotheses.